So as we progress, keep in mind that a system can contain any number of equations or inequalities. In this example, we have a system that contains 4 inequalities, and you can see them here, 1, 2, 3, and 4. And as we learned earlier, if we have more than one inequality on the same coordinate system, an overlap occurs with their regions. Here's the graph of the first inequality here. X plus 11y is less than or equal to 75. Here's its boundary line here. X plus 11y is equal to 75, but this is a shaded region. Here's the graph of 2x plus y that's greater than or equal to 3. Here's its boundary line here and its shaded region, but as you can see, the overlap that's occurring. And if we go ahead and graph the next one, x minus 7y, that's less than or equal to negative 6. And then the final one, x is less than or equal to 9. We have this region here, this geometric shape, and these corners there, those are known as vertices. But we're just going to go ahead and we can just call them corners. But this is where all 4 of the inequalities overlap. This is this darkest region here. That's known as its feasible set. I'm just going to pen it in right here, feasible set. And if you recall, a feasible set is the set of all possible points that simultaneously satisfy each inequality of a system. However, it is cumbersome to draw a system of inequalities on a coordinate system, but you certainly should have an idea of what is occurring. But nonetheless, we can check if a particular point satisfies the system. That is, when we substitute the values of the coordinates of some point into each inequality of the system, if it is true for every inequality, then we know that the point lies within the feasible set. But it has to be true for every inequality of the system. So for this problem, it says determine if the points 2, 4, and 8, 7 are in the feasible set of this system of inequalities here. So we're going to do that. We're just going to substitute the coordinates of this first point for each x and y of each inequality. So we have x plus 11y is less than or equal to 75. I'm going to put in 2x, that's 2, plus 11y, and y is 4. Is that less than or equal to 75? 11 times 4 is 44. 44 plus 2 is 46. And 46 is definitely less than or equal to 75. So it satisfies that inequality. And we'll go down to the next one. 2x. X is 2. 2 times 2 plus y, which is 4. Is that greater than or equal to 3? 2 times 2 is 4, and 4 plus 4 is 8. And 8 is definitely greater than or equal to 3. So it satisfies that inequality. We go to the next one. X is 2 minus 7y. Y is 4. Is that less than or equal to negative 6? 7 times 4 is 28. 2 minus 28 is negative 26, and negative 26 is less than or equal to negative 6. So it satisfies that inequality. And of course, 2, that's x. 2 is less than or equal to 9, so it satisfies that inequality also. So since it satisfies all the inequalities of our system here, then we could say that 2, 4 lies within the feasible set. Now, since we have this graph here of this system, we could go ahead and we can see if that it actually sits in there. So I'm just going to count off 1, 2, and then count up 4. 1, 2, 3, 4. So graphically or visually, we could see that 2, 4 sits right in the middle of our feasible set. So now we're going to see if 8, 7 is also sits on our feasible set. We're going to do the same thing. So we're going to do x, which is 8, plus 11y, and y, which is 7. Is that less than or equal to 75? 11 times 7 is 77. 8 plus 77 is 85, and 85 is not less than or equal to 75. So actually, there's no reason to go any further because this point has to satisfy every inequality. And already right off the start, it doesn't satisfy the first one. So we already know that 8, 7 does not satisfy this system of inequalities. But for the sake of exercise, we're going to go ahead and we're going to check the other three inequalities here. So we have 2x, that's 2 times 8, that's 16, plus 7, is that greater than or equal to 3? And 16 plus 7 is 23, and 23 is definitely greater than or equal to 3, so it satisfies that one. X minus 7y, that's 8, minus 7 times y, or 7 times 7, is that less than or equal to negative 6? 7 times 7 is 49. 8 minus 49 is negative 41. Negative 41 is less than or equal to negative 6. And of course, for the last one here, 8 is of course less than or equal to 9. So it does satisfy the last one. So it satisfies the other three inequalities, but it has to satisfy all of them in order to be in the feasible set. So we're just going to go ahead and we're going to graph it just to see if it actually is visually. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, and then up 7. 1, 2, 3, 4, 5, 6, and 7. Here it is right here. And as you can see, it is not sitting inside our feasible set, which we already knew by slugging it in and checking it for each inequality. So we can say that 2, 4 is in the feasible set of this system of inequalities, but the 0.87 is not. And there you go.